Last summer, my basil plant almost died because I followed the advice on the back of the seed packet. The packet said to harvest leaves as needed and pinch off flowers when they appear. I did exactly that. By August, the plant looked like a small green tree, woody at the bottom, leggy in the middle, and topped with a tight little cluster of flower buds that I kept dutifully snipping off every 3 days. The leaves at that point tasted like soap. Not faintly soapy, aggressively soapy. I bought a new transplant from the nursery the next morning, and the woman at the register, without looking up, said, "You let it flower." I told her I'd been pinching the flowers off for weeks. She said it already flowered. You just didn't see it. She was right, and the seed packet was wrong, and the gap between those two statements is a much stranger story than most gardeners are told. Basil is what botanists call a facultative short-day plant with a strong thermal trigger and the conventional wisdom that you can stop bolting. The plant's shift to flowering by pinching off flower buds fundamentally misunderstands what bolting actually is. Bolting isn't the appearance of flowers. Bolting is a developmental switch that happens inside the shoot tip, often 2 to 3 weeks before any flower is visible to the human eye. By the time you see the bud, the plant has already committed. The mechanism is now well mapped. A gene called flowering locus T, or FT, is expressed in the leaves in response to specific combinations of day length and temperature. The constans protein activates FT expression during long days, and the FT protein then travels down the phloem, reaches the shoot apical meristem, and reprograms it from producing leaves to producing flower structures. This isn't a metaphor, it's a measurable, traceable signal governed by the plant's circadian rhythm. A 2009 paper in the Journal of Experimental Botany on Arabidopsis flowering established the basic architecture, and later work has shown the same FT-driven pathway operates across nearly every flowering plant studied, including basil. Once that signal arrives at the meristem, the tissue that would have made a leaf instead makes a sepal. Pinching the flower bud off at that point doesn't reverse the signal, it just removes the evidence. That's why your basil keeps trying to flower no matter how diligently you pinch. The plant isn't being stubborn, the instruction has already been written. What sends the instruction matters more than what you do after it arrives. A study published in Folia Horticulturae by Frąszczak and colleagues grew 2 sweet basil cultivars, Kasha and Walla, under 3 day-night temperature regimes and 2 photoperiods, 12 hours and 16 hours. The plants under 16 hours of light flowered measurably faster and produced less leaf area than the plants under 12 hours, regardless of cultivar. Temperature mattered too, but light duration was the dominant variable. For a home grower, that's the single most useful finding in the basil literature, and almost no one mentions it. The reason your basil bolts in July isn't the heat, it's the 15+ hours of daylight your windowsill is now receiving. The flavor change isn't a separate event from the flowering, it's the same event. When basil transitions toward reproduction, the chemistry of the essential oil in the leaves shifts on a predictable schedule. Research by Frąszczak's group analyzing the Kasha and Walla cultivars across 3 growth stages, vegetative, flower bud, and full flowering, found that linalool, the compound responsible for basil's sweet, floral, pesto-defining aroma, ranged from 55.4 to 69.8% of the essential oil. It peaked at the flower bud stage, then declined. Eugenol, the clove-like compound, dropped from the start of flowering through the end of flowering. A separate study in the Journal of Agricultural and Food Chemistry tracked individual leaves and found that as leaves matured, eugenol converted into methyl eugenol, the compound responsible for the harsher, more medicinal flavor that gardeners describe as bitter or soapy. In some basil cultivars, methyl chavicol becomes the dominant compound, creating different flavor profiles entirely. The plant isn't accidentally ruining its own leaves, It's reallocating its chemistry toward the reproductive tissues, which now need protection from insects more than the leaves do. When you taste the bitterness, you're tasting the floral transition completing itself. Which brings us to the experiment a viewer asked me to run, because the most popular folk explanation for early bolting is root binding. The theory goes that if you keep basil in a small pot, the cramped roots will signal stress to the plant, which will then panic and flower early. I planted 3 basil seedlings from the same seed packet on the same day, under the same grow light, running a 16-hour photoperiod with identical watering. The only variable was pot volume. A 4-inch nursery pot, a 1-gallon container, and a 5-gallon container. I tracked them for 42 days, looking for the first visible flower bud. The 4-inch pot bolted on day 29. The 1-gallon bolted on day 31. The 5-gallon bolted on day 32. A 3-day spread across a 13-fold difference in soil volume. The root binding theory isn't exactly wrong. Cramped roots do produce mild stress signals, but the effect size is trivial compared to the photoperiod signal hitting the leaves every morning. If you want to delay bolting, fixing your pot size will buy you days. Fixing your light environment will buy you weeks. So here's where this lands for you. If you're growing basil on a windowsill or in a backyard pot right now, the plant in front of you is running a biological countdown that was set the moment the days got long enough to trigger FT expression. You can't stop the countdown by pinching off the visible buds, because by the time the buds are visible, the signal has already arrived at the meristem. What you can do is slow the countdown itself. That means choosing a cultivar bred for delayed bolting. Varieties like Genovese Compact Improved, Prospera, Everleaf, or Thai Basil were specifically selected for reduced photoperiod sensitivity. It means harvesting aggressively from the top down, removing the entire growing tip every 10 to 14 days, which forces the plant to restart its developmental clock from a lower node. And if you grow indoors, it means reducing your grow light to 12 hours because your basil doesn't care what the calendar says. It cares what the leaves are reporting. One more piece of evidence, because it changes how the whole picture reads. A study in spinach published in HortScience demonstrated that bolting in leafy greens can be delayed indefinitely by controlling photoperiod during the transplant production phase through a process similar to vernalization. Plants raised on short days as seedlings refused to bolt even when later moved into long-day, high-temperature conditions of 17 to 37 degrees Celsius. The floral commitment can be postponed at the source. That's now standard practice in Japanese closed-system transplant nurseries. The home gardening industry, which sells you a new basil plant every 6 weeks, has not adopted it. I think about the woman at the nursery register sometimes. She knew, in the way that people who handle thousands of dying basil plants come to know, that the flowering had happened weeks before I noticed it. She didn't have the FT gene or the linalool curves or the Polish photoperiod study. She just had the pattern repeated across every customer who walked in holding a bag of soapy leaves and a confused expression. What strikes me looking back at it is how often this same gap shows up in houseplant care. The snake plant that suddenly pushes out a flower stalk after years of nothing, the same FT-driven switch, triggered by a different combination of stress signals. The aloe that blooms once and then seems to lose vigor, same architecture, different timeline. Even the orchid that flowers gorgeously and then refuses for 2 years, I traced that one through its own mystery in an earlier video, and the underlying mechanism is closer to basil than most people would guess. The plants on your windowsill are running the same handful of programs. The signals just arrive in different orders. The seed packet on the back of my second plant said the same thing as the first one. Harvest as needed. Pinch off the flowers. I planted it anyway. It bolted on schedule on day 30, almost to the hour. The third plant, the one I'm growing now under a 12-hour timer in a 5-gallon pot with the top pinched out every 2 weeks, is on day 51 and still hasn't shown a bud. The countdown can be slowed. It can't be stopped. The woman at the nursery already knew that. She just didn't have the data.